Hi guys, this is the video for the 6.6 and 6.7 practice mini test that's in your guided notes. So it'd be really great if you guys could try as many of these as you can do on your own, and then use this video to kind of fill in what you're not sure about, or just to double check that your answers are right. And I'm hoping this doesn't come out too wobbly, but I did my best to sort of jerry-rig the camera, and it's like rubber banded to a couple of boxes on top of a glass jar. So hopefully this'll work. So the first three say solve the equation. Here I have an exponential equation, and where the variable is, I can't really get to it in exponential form. So I like to often kind of ask, like, can we, write this with a 3 on both sides? So could I rewrite 10 with base 3? If this were like a 9 or a 1/9 or an 81 or something like that, I could, but as a 10, I cannot. So what I'm going to do is I'm going to rewrite this in log form. So I'm going to whale it. I'm going to write log base 3 of 10 equals x. And now I'm going to calculate this using my change of base formula. So x is log 10, so log 10 of 10 over log base 10 of 3. So I'm rewriting this using common logs. And then I can have my calculator do that part for me. So when I punch this into my calculator, I get x is about 2.0959. So I'm going to say 2.096. And that makes sense, because if I raise 3 to the second power, that would be 9, and 10 is a little bit bigger than 9, so my power should be a little bit bigger than 2. For question number 2, I'm just going to put the 2 in a circle so we can see that's separate from the question. I have 5 to the power of 3x equals 42. And again, this isn't really written in a form where I can get x alone. So, and again, because 42 is not a power of 5, I can't rewrite the two sides with the same base. So I'm going to whale it. So I'm going to say log base 5 of 42 equals 3x. Now, because this equals 3x and I want x alone, I'm going to divide both sides by 3. But before that, I do that, I'm going to say 3x is, and now I'm going to use my change of base here, log 42 divided by log 5. And now I'm going to divide both sides by 3. So this is kind of a complex fraction. It's a fraction within a fraction, but I don't really care about that because it just tells me how I'm going to punch this into the calculator. So the way I'm going to do that is I'm going to say log 42 divided by log 5, enter. And that gives me like 2.3 and some change. And now I'm going to divide that by 3. And I get x is about 0.774. And if I were to plug that in, 3 times 0.774 is like 2 and some change. And 5 to that power, 5 to the second power would be 25. And 5 to the third would be 125. So this should just be over 2 to achieve something like a 42. So for question number 3, I have 6 times e to the power of negative 2x plus 3 equals 8. So I want to try to get the x alone. I need to move all this other stuff first, and I want to try to get this like e to the negative 2x by itself. So the first thing I'm going to do is subtract 3 from each side. And now I'm going to divide each side by 6. So I have e to the negative 2x equals 5/6. And you don't need to turn that into decimal. It's a little bit cleaner if you keep it as a fraction. Now, since my variable's in the exponent, I want to take the log of this. So I'm going to rewrite this in log form. So log base e is log natural. So log natural of 5/6 equals negative 2x. So again, to get x alone, I'm just going to divide both sides by negative 2. So I have x is all of this stuff. So again, this is not log natural of 5. divided by 6, it's the log natural of 5/6. So what I need to do is hit log natural, and then in parentheses, I'm going to do 5 divided by 6, close parentheses, enter, and then I'm going to take that number and divide it by -2. And x is going to be about 0.091. So I went ahead and I checked that number. I plugged it into the calculator, and it comes out to work out, so that's really good. Moving on, the next problem is related to Newton's law of cooling. So we had done a problem like this in class with Alicia. That was the like African stew that needed to cool down. So this problem, essentially the same problem, different context. It's hot cocoa that's way too hot to drink. So what we're going to do is, if you look at the problem, we can sort of assign roles to each of these values. So it says that the hot cocoa, when you buy it at the food truck, is 195 degrees Fahrenheit. That's the current temperature, and it's way too hot to drink right now, but that is T sub 0. That's the initial temperature. I just realized you probably can't see this in the screen. Let me move it over. So initial temperature right now, 195 degrees, okay? You can drink it when it hits 175 degrees. So that's sort of like the final temperature after a certain amount of time. So that's 175. The temperature outside, so that's the surrounding temperature, T sub R, is 35 degrees Fahrenheit. So certainly chilly out. And then the R, so this is the cooling rate is 0.025. And the question is, how long do you have to wait to drink the hot cocoa? So we're solving for T. So we're going to plug all this good stuff in. So T, 175, equals T sub 0, 195, minus T sub R, 35. So this is like the difference between the temperature of the cocoa and the temperature outside. Times E, which is a constant, times negative 0.025 T, that's our unknown, plus T sub R, which is, again, 35 degrees. So I'm going to pause the video for a minute and just start cleaning this stuff up. So I just went ahead and subtracted these numbers. That's our coefficient on the E, subtracted 35 from each side. Now I'm going to divide each side by 160. So I went ahead and divided each side by 160. I cleaned up 140 over 160. It's about 7, well, it is exactly 7/8. So E to this gnarly power is 7/8. I want to solve for T, so I need to rewrite this as a log natural. So I've done that over here, and I can kind of walk you through each individual step. So my first step is I just rewrote that with the E on the left. I like it better that way. Rewrote it as a log, so I have log natural of 7/8 equals negative 0.025 T. Divide both sides by negative 0.025 T. So I have T equals all of this. Okay, and when I plug that into a calculator exactly as I see it, I get T is about 5.34. So this is about a third. So a third of a minute is about 20 seconds. So I said it would take about 5 minutes, 20 seconds for the hot cocoa to cool down so that it's the right temperature to drink.